At a couple of scenarios where we've solved triangles giving two sides and an angle. And one of those we had no solution. And the second one we had a case where, in that first case where no solution, we had an obtuse angle that we were given where we had no solution. And then we did one with an acute triangle that had only one solution. And now we're looking at the ambiguous case where we may in fact have two solutions and we're not actually sure which one is the solution, but we know there's two possible solutions. And so here we've got a triangle, and we're given that we've got triangle ABC, and we're told that angle A is 47 degrees, and the side opposite it, A, is 15, and we're given that side B is 18, and what we're trying to discover is, well, what could be angle B? That's our first step in finding the two solutions. And this is where we run into the fact that there could be two possibilities for that angle measure of B. And that's because if we look right here, A is less than B. And that puts us into this possible scenario right here. However, if it is in fact going to be that we have two solutions, the height must be, the measure of the height of the triangle must be less than side A in this case. And so over here in the green, we calculated the height. I sketched in an altitude there, which creates it's perpendicular to side AB, which creates a right triangle, and where I can then use the sine of 47 equals the height over side A, which then converts to 18 times the sine of 47 is going to equal the height, and the height we discover is 13.2, and because that's less than 15 in this case, less than side A, we are in fact going to have two possible solutions. So let's go about the first possible solution and then to the second. All right, so here's our triangle. We've got side A is 47 degrees. We're given that side A is 15, side B is 18, and we're trying to figure out what is sine B, angle B, excuse me, if angle B is acute. Well, we can then say that sine of 47 over side A, 15, is equal to the sine of B over 18, such that 18 times the sine of 47 over 15 equals sine B. But I want to find that angle measure, so I'm going to use the inverse sine. So let's see, I got a second sine, that's going to give me the inverse, and I got 18 times the sine of 47 divided by 15. And that's equal to, rounded to the nearest degree, that means that 61 degrees is approximately the angle measure for B, if it should be acute. Now from there we can find angle C. Angle C is going to equal 180 degrees in a triangle, minus 47, what we know, minus 61. And that's going to equal 180 minus 47 minus 61 is equal to 72 degrees. So angle C is 72 degrees. And then to find side C, we'll again go back to the sine of A, sine of 47 over 15 equals the sine of 72, angle C, over side C, which we do not yet know. And so let's see, I'll do it longhand. C is equal to the sine of 47, which is equal to 15 times the sine of 72. And side C then is going to equal 15 times the sine of 72 over the sine of 47. So let's see what the side measure C then is going to equal. And we got 15 times the sine of 72. And we're going to divide that by the sine of 47. And that comes to, rounded to the nearest tenth, of 19.5. So side C then is 19.5. All right, now we're going to go to the second case and ask the question, well, what if B was acute? Because we can have two possible solutions. So if we found, if B was acute and it was 61 degrees, what would it equal if it was an obtuse angle? Well, we could then say that angle B then must equal 180 less 61. So it's either going to be 61 or it's going to be 119. Okay, so now it's got to be one or the other. It's either going to be 61 degrees like we found if it was acute, but if it's obtuse, it's 119. The side measure is going to stay the same. Now, if it's 119, what is angle C going to equal? Well, then it would equal 180 less 47 less 119. So it's going to change the measure of angle C. So 180 minus 47 minus 119, and that would be 14 degrees. Okay, so if B is obtuse with a measure of 119, then C would only measure 14. And now we go about finding a new measure for side C. So we still stay with what we were given, the sine of 47 over 15, angle A over side A, and that would be equal to the sine of 14 over side C. And side C is times the sine of 47 is then going to equal 15 times the sine of 14. And side measure C is going to equal approximately 15 times the sine of 14 over the sine of 47. And that's going to approximately equal, well, we don't know yet, 15 times the sine of 14 divided by the sine of 47 is rounded to the nearest tenth is 4.96. So rounded to the nearest tenth would be 5.0. All right, you may want to watch this again. This is a little bit complex, I find, but hey, it's doable. Why? Because we're expert mathematicians.